All right, let's jump right into this explainer. We are starting off with a real-world horror story today because we really need to look at exactly what happens when we build these complex AI systems that we, well, don't fully understand. It's just so easy today, right? You install a library, you follow a quick tutorial online, and boom, suddenly you've got an AI agent up and running. It feels like total magic. But the thing is, when that magic breaks, it breaks in ways that can be absolutely devastating to your wallet.
Literally, look at this quote, straight from our sources. I watched a $200 bill appear on an AWS account overnight. And you know what the really scary part here is? This didn't happen because the system crashed. It didn't throw a massive error. Actually, if you looked at every single monitoring dashboard, the system was perfectly healthy. It was doing exactly what it was told to do, just quietly bleeding money while the entire engineering team was fast asleep.
And honestly, this brilliantly illustrates the whole danger of treating AI like it's just magic. For 6 solid hours, an AI agent ran in a continuous, endless loop. Why? Because the builders treated the system like it was somehow, self-managing. They completely forgot to include a basic stop condition. So it just kept calling the OpenAI API over and over on every single iteration for 6 hours. Guys, building systems like this isn't actual engineering. It's literally just relying on hope with a keyboard.
Section 1. The mental model.
Okay, so to understand why an agent can just run away with your company credit card, we need a really solid mental model of what AI actually is under the hood. Every single modern AI system you interact with basically boils down to 4 main pillars. First, you've got memory, which is how this system retrieves facts. You'll often hear this called RAG. Second, you have thinking, which is driven by the large language model and its tokens. Third, you have actions, where AI agents actually go out and do things like browse the web or run Python code. And finally, measurement, or evals, to see if the whole thing is actually working. All of this is glued together by context engineering, which is just how we control what information the AI actually has access to at any given moment.
Section 2. Tokens in context windows.
So, let's zoom in on that thinking pillar for a second. We need to look at how an AI actually processes the text we feed it, and it all starts with tokens. When you type a prompt, the AI doesn't read words the way you and I do. It actually chops your text up into these tiny little fragments called tokens. A short word might be 1 token, a really long word might be 3. And here is where we hit a massive physical limitation. Imagine the AI's memory is a literal whiteboard in a conference room. We call this the context window. You can only write so many tokens on that whiteboard, right? When the whiteboard is 100% full, the AI has to literally take an eraser to its oldest notes just to make room for new incoming messages. If critical instructions get erased, well, the AI completely forgets what it was supposed to do in the first place.
Section 3. Transformers and Attention.
Once we have our text broken down into those tokens on our whiteboard, the AI needs an engine to actually process them. And this brings us to the architecture that fundamentally changed AI forever back in 2017, the Transformer pipeline. This is the exact engine powering ChatGPT, Claude, Gemini, Llama, all of them. And here's the secret. It is not a conscious brain. It's a step-by-step prediction machine. It takes text, turns it into tokens, translates those tokens into mathematical coordinates that we call embeddings, runs them through something called attention layers, and then just mathematically predicts what the very next token should be. Just one single token at a time.
Now, the absolute crucial point here is understanding those attention layers. As humans, we read word by word, left to right. But an AI using attention, it looks at the entire sentence, or honestly, the entire document all at once. It examines every single word simultaneously to figure out which words are mathematically related to each other. This is exactly what allows an AI to grasp the context of some long rambling paragraph, or perfectly translate between 2 languages that have completely different sentence structures.
Section 4. Model distillation. Now, you might be wondering, these transformer models are usually massive, right? They require giant server farms just to run. So how do we get AI running locally on our phones or laptops? We use this brilliant technique called model distillation. Think of it kind of like this. A massive 400 billion parameter AI model is like a PhD physics professor who knows all the incredibly complex math behind gravity. But a tiny AI model, that's like a high school student who really just needs the basic formula to pass their test. You don't hand the high school student the professor's massive, dense textbook. Instead, the professor just gives the student a cheat sheet of curated answers to practice problems. We literally train the small model to mimic the exact outputs of the massive model. The result is this tiny, incredibly fast AI that can run right on your phone, but it behaves surprisingly like its giant parent.
Section 5. Hallucinations, Bias, and Risk.
But, and this is a big but, understanding that these models, whether they are the giant professor or the tiny student, are really just predicting probabilities, brings us to a pretty harsh reality about their risks. We have to fundamentally shift our expectations here. What we kind of think AI does is act like a massive database, right? We ask a question, and it retrieves a hard, factual answer. But what AI actually does is predict the next most likely word based on statistical patterns it learned during training. Remember, it is a pattern prediction machine, absolutely not a truth machine.
Because it is just predicting plausible-sounding patterns, it can act incredibly confident while generating completely false information. We call this a hallucination. And it's so important to get this. The AI isn't actively trying to lie to you. It has no concept of a lie. It's just generating a sentence that statistically sounds correct, even if it has to totally invent a fake research paper, or make up a statistic, or suggest a software tool that literally doesn't even exist to finish the sentence. This is exactly why you can never, ever rely on AI for purely factual tasks without checking its work.
And because it learns these patterns from massive troves of human data, well, it inherently learns all of our prejudices too. AI bias isn't just some technical glitch or a tiny bug you can easily patch out. If a hiring algorithm is trained on 20 years of biased historical hiring data, it's just going to predict that the company wants more of the exact same kind of people. In 2026, relying on unaudited AI for things like medical plans or facial recognition isn't just irresponsible, it's straight up dangerous.
Section 6. Evals and AI Governance. Which actually brings us full circle, right back to our autopsy of that $200 overnight disaster. How do we stop these risks? How do we actually build safely? Well, you simply cannot build a production-ready AI system without evals. Evaluations are the strict measurement protocols that test your AI. Before you ever deploy an agent into the wild, you need to know, does it have guardrails? What is its exact stop condition? Does it have error handlers built in from day one? If the engineering team in our very first story had built a simple eval that just said, hey, if this loop exceeds 10 times, stop everything and alert a human, they would have saved their money and, frankly, their pride.
And look, this isn't just a best practice anymore, it is becoming the law. With regulations like the EU AI Act being heavily enforced today, explainability is completely mandatory. If your AI rejects someone for a bank loan, you have to be able to explain exactly why it made that decision. Organizations are quickly waking up to the fact that having clear governance, running bias audits, and maintaining strict human oversight is no longer optional. A careless AI deployment today leads straight to massive reputational damage and some very, very heavy regulatory fines.
So I want to leave you with this final provocative thought. When patterns perfectly align with reality, AI is incredibly, almost unimaginably powerful. But when they don't, it breaks in very predictable, very costly ways. Take a hard look at the systems you or your company are building today. Ask yourself, is your AI strategy actually built on solid engineering, strict evals, and clear governance? Or are you just waiting to wake up to your own overnight disaster, running on nothing but hope with a keyboard? Thanks for joining me on this explainer. I really hope it gave you a whole new way to look at the systems we interact with every single day.